Hi, and welcome to our next Level 2 Calculus video. In this video, we talk about rates of change. A rate of change is the official way of talking about a gradient of a function. When any two variables are linked by a formula, we can determine the rate of change or the gradient. The gradient of a line is a measure of how quickly y is changing in relation to x. Thus, when we say dy dx, which is the formal way of writing a gradient, we say it is the rate of change of y with respect to x. I prefer a less formal way, basically, and I say the d means to change, so a change in the y over the change in the x. All right, we've got two examples to show you and see if you can get your head around what this means. Example 1, a circle is increasing in size. We're going to calculate the rate at which the area is changing with respect to the radius, when the radius of the circle is 12. So the word rate means gradient, so we're going to have d something over d something. And since we say the area is changing with respect to the radius, we're going to have dA over dr. So the rate at which the area is changing with respect to the radius is written as dA over dr. So we're going to write the area rule down. Area of a circle is pi times radius squared. And we're going to now calculate dA over dr, the gradient of the area rule. So here's what happens. The 2 comes out the front, times is by the pi, and then the r squared drops down by a power of 1. We take 1 off the power, and this will simplify down to 2 pi r. Now, if you're thinking, what the heck just happened there, just think of the a as your y, the pi is just a number like 3, and the r squared is your x squared. And you know how to differentiate that. The 2 comes out the front, times is by the 3, and then we take 1 off the power. So it's the same thing. The 2 comes out the front, times is by pi, and then we take 1 off the power of r squared. So this is the gradient rule for the area rule. Now we were asked to work out what is the gradient, the rate, when our radius is 12. So we're going to substitute 12 into our gradient rule. So the gradient rule is 2 pi r, so 2 times pi times 12, which is the radius, and that gives us 24 pi, or 75.4 if you prefer decimal. Now, to try and explain what this means, dA dr is 75.4. Well, we're going to write this as 75.4 over 1. The area of units for area is centimetres squared, and the units for the radius is centimetres. So what we're going to say is, when the radius of the circle is 12 centimetres, the area is changing at a rate of 75.4 centimetres squared for every 1 centimetre change in the radius. It's like a gradient, rise over run. All right, example 2. Boyle's law is a rule that links the pressure of a gas with the volume of the gas. For a particular mass, P is equal to 60 divided by V. We're going to find the rate of change of the pressure with respect to the volume when the volume is 20 centimetres cubed. So rate of change is a gradient, so we're going to have d something over d something. And since it says pressure with respect to volume, we're going to have dP over dV. So the rate at which the pressure is changing with respect to the volume is dP dV. So let's write down the pressure formula. Let's put V to the power of 1. Let's bring up the power of 1 to the top with the 60 and make it a power of -1. This is just some algebra skills we're practicing. Now let's differentiate that with respect to V. So the -1 comes out the front, times is by the 60, and then we take away 1 off the power of -1 to get -60 times V to the power of -2. And when we put the V to the power of -2 back to the bottom, we get -60 over V squared. This is the gradient rule. dP dV is a gradient rule for the pressure rule. Now we were asked to work out what is the rate when the volume is 20, so we're going to substitute 20 in and get -60 divided by 20 squared, which gives us -0.15. Right, these are just two examples we've shown you that involve rates of change. You really need to go and practice and find as many as you can until you're feeling much more confident about this. Thanks for watching.